Here we are with Math 1 Unit 2, Lesson 3.1. So we're still dealing with sequences. So on these first ones, we're just using some equations and finding terms. Okay. So looking at these, the fourth term in this sequence. So that means we'd want a sub 4 instead of a sub n. So we change that n to 4. And then we would just simplify. Now, there's another way we could do this as well. Okay, we could, realizing that we're looking for this fourth term, realize that our starting number is negative 12, and our growth is we're adding 10 each time. So we could do that as well to get our numbers as well. Okay, so the fourth term should be 28. Okay, so we can use a table if we understand those pieces, and remember, for an explicit formula, it's a sub n equals, usually I write this number first, our starting number, plus our growth times the n, so that common difference times n. Okay, so not 10, let's actually put d times n. So if I look at this, 10 times 4 would give us 40 minus 12 would give us 28. So whichever one you determine is the easiest way to do it, by all means, use that way to do it. So the second one, what is the fourth term of this? So we'd go a sub 4 equals 5 times 4 plus 3. 5 times 4 is 20, plus 3 gives us 23. Once again, I could say there's my starting number, my zero term. We're adding 5 each time. That's my growth. And we could figure it out that way. So 8, 13, 18, 23. And that's all there is to these ones. Okay, these first ones anyway. Now the next two are wanting us to graph the first 5 terms. Okay, so we need to figure out the first 5 terms. And often when they say the first 5 terms, they would mean not counting the zero term. Okay, so, but looking at our equation the way they wrote it, right? A sub n equals our common difference times n plus our zero term. So our zero term would be negative 7, and we're adding 5 each time. So negative 2, positive 3, then 8, 13, 18. So now if we're looking to graph that, right, we would need to, let's actually go over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5. So there's 518, right? Then 413 is next. So 4, then up to 13, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Or actually 13, right? 4, so right there. Okay. Then 3, 8. So 3 up 8. About right there. Okay. 2, 3. Right about there. 1, negative 2. So right about there. And then finally 0, negative 7. So right there. Okay? So there's our graph. Now, because we're dealing with a sequence, there's no numbers in between here, so we don't connect the line. You don't do that. You leave it like that. Alright, so now let's do it for number 4. So the same process here. So the first 5 terms, so 0, 1, 2, 3, 4, 5. Okay. Now looking at this one they're using the geometric. We've been doing arithmetic on all these ones. Now notice we have a power, so that's geometric. Okay. Now the way they wrote this is a little different than the way I like to, because they went with the first term. They went a sub n equals that ratio to the n minus 1 minus 2. Okay, so that minus 2 is like the a sub 1. So that'd be negative 2 would be right there. Okay, because r to the 1 minus 1 is r to the 0, which is 1. So 1 minus 2 would actually give us, it bumps it down, so it would be negative 1. Okay, so this one's a little trickier to deal with because of the way they wrote it. But we are timesing by 2 each time, so then the next one would be negative 2, then negative 4, then negative 8, then negative 16, and we'd start at negative 1/2. Okay, so things just got bumped down a little bit, which sometimes happens. Okay, so to graph that, we'd go 0 and 1/2, which would be right about there. We'll graph it on the same one. Okay, then 1, negative 1. So 1 down to negative 1, right there. Then 2, negative 2. 2 down to negative 2. And it looks like it's a straight line right now, right? But because it's geometric, it's not going to be. Okay, then 3, negative 4. So about 3 down to negative 4. Then 4, negative 8. So we need a negative 8. So 4, negative 8. So now you can see that more of that curvature, huh? And then 5, negative 16. So out to 5, down to negative 16. Now once again, we always want to draw the line usually, but because we're dealing with sequences, sequences don't have the middle numbers, so you leave it just as the dots. Okay? Alright, so now taking a look at number 5. What is the third term in the sequence given by a sub n equals 3 times 5 to the n minus 1? So if we want to find 3, we just go a sub 3 because we're looking for the third term. 3 times 5, 3 minus 1. So we get 3 times 5 to the 3 minus 1 is 2. 5 squared is 25. Times that by 3, we get 75. Okay, could we make a table with this? Yeah. Now normally, okay, this 3 would be our starting number, and then we times by 5. So we'd have 15. Okay, the problem is because of that n minus 1, they're actually starting with the first term. So this 3 would be 3. Then this would be 15, and then our third term would be 75, and so on. Going backwards, that'd be 3 divided by 5 for our 0 term. Because whenever you have that n minus 1, that's the way you have to think. Okay, which number 6, it's the same idea, right? We've got going to the fourth term this time, but you've got the n minus 1. So our first term is actually 13, that starting number. And we're timesing by 2 each time. So that'd be 26, that'd be 52, right? And then we would get 104. So our fourth term would be 104. If we wanted to use a formula, I'd just go a sub 4 equals 13 times 2 to the 4 minus 1, which would be 2 to the third. 2 cubed would be 2 times 2 times 2, which is 8. Then 13 times 8 be 42. 8 times 1 is 8, plus 2 is 10, so 104. So it still gives us that same answer. Alright? Alright, now number 7 and 8 want us to complete and graph the sequence. So we've got 2, 6, so if we made this table, that would be our first term, second, third, fourth, fifth, and sixth. So 2 to 6, 6 to 18, looks like our constant ratio is timesing by 3. So 54 times 3 would give us 12, 15, 162. So that one would be 162, which if we times by 3 gives us 486. Okay, so then we'd need to graph these. So let's make ourselves a graph here. Okay. Now we got to get pretty high up to 486, right? So we go 2, 6, 18, 54, 162, 486. So maybe if we called this 500. So this would be like 250. So from 250, cut that in half. That would be 125. That would be 75. Okay, cut that into thirds, and that would be 25 and 50. So, it should look something like that. Okay, now to graph this, so we'd go 1, 2, so that's going to be really small down there. Then 2, 6, barely above it, right? Then 3, 18. Okay, and I probably need to go like this, give myself a little bit more room here. I know that'll look kind of weird, but okay, to help us out, right? Oops. Okay, there we go. So I go 1, 2, 2, 6, 3, 18. It's a little higher. 4, 54. Right about there. 5, 162. So 5, 162, right about there. And then 6, 486. So 486 would be pretty close to up there. Now, if I wanted to go backwards to the 0 term, I would just divide by 3 and get 2/3. So for 0, it would be clear down at the bottom. And once again, because I'm dealing with a sequence here, I'm not going to connect the dots. I'm just going to leave it how it is. Okay. Now, if we look at number 8, same idea. Okay. Once again, we'd go 1, 2, 3, 4, 5, and 6. 13 to 21. Okay. 21 to 29. That would be adding 8. 13 to 21. We're adding 8 each time. So this time we have a common difference. So we're adding 8. Okay. So a sub 5. Adding 8 to that would be 45. Then it would be 53. Okay. So we'd graph that. 113. 113 would be right about there. A little off probably. 221. 221 right there. Okay, 329. 329. Oops, a little off. And my 21 might need to be a little bit lower. Then 329. Then 437. Okay, these ones are tough. This should be more in a straight line, because it's growing by that addition. But since my scale is so big, it's kind of harder to see that. 545, 545, and 654. Okay, which would be a horrible one, and if I wanted to go back to the 0, it'd end up being 5. Okay, but once again, we just draw the dots. We don't connect them. Alright, so there's number 8. Alright, 9 and 10. A radio show breaks for news every 30 minutes. After every fourth news report, the newscaster reads the daily sports highlights. If the radio show began at 12:01 p.m. and the first news report was read at 12:31, p.m. At what time did the daily sports highlights be read? Okay, so they break for news every 30 minutes. After every fourth news report, they read the daily sports highlights. Okay, so you'd kind of want to make a table using the times, right? So we have 12:01 for the first time the news is done, then 12:31, then 1:01, 1:31 would be the fourth time, right? So that would be when we would hear the sports. Okay. Oh, hold on. That's like our zero term, isn't it? And so we need the actual fourth, which would be 2:01. Okay? So at 2:01 p.m., that's the first time they would read the daily sports. Okay? I don't think it wants us to go further. We could keep going and go every fourth, but I don't think we need to on this one. So number 10, water stations are set up periodically through a marathon route. After the first water station, the rest of the water stations are set up every 3.5 miles. If the first station is at the 5-mile mark, at what mile mark will the fifth water station be? So kind of a similar idea. So the first station is at the 5-mile mark, right? So it might be a good idea to draw a picture. So at 5 miles, we have the first water station, right? Then every 3.5, we'd have the next one. Right? So third, fourth, and fifth. So at what mile mark will the fifth be? Well, we started with 5, right? If we're making a table, that's like the zero term. Then the first one, actually that's like the first term, isn't it? That's the first one. And then we would add 3.5 to the second, third, fourth, till we get to the fifth. So 8.5, 12, right? 0.5 would make it 9, 3 would make it 12, 15.5, and then it would be at 19. So at 19 miles is when the fifth water station would be. And there we go.